So what we're talking about today is getting the most out of batteries and solar. A2EP is known for energy demand side of things and how people use energy. But the way you use energy and the supply of energy is so much intertwined now. Energy is not just on a tap. It's very much a two-way thing. So we need to also start looking more at solar and getting the most out of that and batteries. And so with that, that's why we're having this webinar here today. A few other drivers is battery prices are coming down, and certainly they're becoming more economical and looking like it's going to be a pretty standard piece of kit that you have in your toolbox to decarbonize and optimize your energy costs. And we really want to talk about batteries and options for them because we've done a study on energy service companies and looking at energy as a service and what have you. And what we really found is that as you move from, it's fine to have your own solar, but as you start having your own battery, then the complications and getting the most out of that battery, we know is very hard to do on your own. You need a partner. That's one recommendation for sure. The other part of this story, and don't know if anyone can pick which state that's coming from, is this volatility of electricity prices and that becoming an opportunity for you. As you'll see this one here, a hell of a lot of time from the very bottom of that graph in negative price territory at minus $100 a megawatt hour. Now, will that go on forever? No. As the coal fleet and what have you is retired, we're not going to see that, but it looks like we've got this for several years. And I understand that we're getting up towards nearly 25% of the hours on the national electricity market are now in sort of negative territory. And this was taken just from today from Queensland, it was. So joining me here today to run through that, we have about four fantastic companies. We've got Grid Beyond, AZO, and Energy and Carbon Solutions, as well as Patties Food Group. And we're going to start off today with talking about funded batteries. And to do that, we've invited Stace Zamtisidis from Grid Beyond and Lisa Bulk. Quick introduction for Stace. This is a professional engineer, worked with Clipsal and Schneider for many years. He's been all around the world, actually, a lot of travel and a lot of work in different countries. And so bringing a good international flavour and understanding of energy systems and energy markets. He's the director responsible for battery storage and EV charging programs within Grid Beyond. Also joining and presenting with Stace is Lisa Bulk. More than 20 years experience across many different sectors from property and renewable energy and construction, and has been with Grid Beyond since leaving AGL a few years back. Lisa is the National Commercial Sales Manager, and between them we are in very good hands to learn about funded batteries. Lisa, I'll hand over to you to start sharing and take us through it and let us know about funded batteries.
Today's presentation is a short discussion on the topic of funded batteries, and that's followed straight after with Lisa's real-world case study of a project that we're working on. My introduction serves three purposes. The first is an introduction to the company Grid Beyond, a brief discussion of Grid Beyond software solutions, and then an overview of front-of-the-meter and behind-the-meter battery storage systems, just to get the definitions right. So who we are. Grid Beyond is a global leader in managing assets of all types at the grid edge. We're a UK-based company, but we operate in Europe, Japan, Australia, and North America. We have over 5 gigawatts of assets under management, where we've enrolled it into our platform to trade, and our customers include utilities, network operators, financiers, and developers. Our software solutions are used to optimize and manage major energy sites, such as data centers, water treatment plants, manufacturing facilities for steel, cement, glass, as well as enrolling large EV charging infrastructure projects for demand services. We provide software solutions for battery storage assets from the meter, as well as fund the development of behind the meter battery storage assets, which is the topic today. Our expertise helps to unlock energy flexibility, create valuable income streams for our customers to support their financial sustainability, and provide valuable grid services to the network operators. Grid Beyond has built a large and diversified customer base, and these are some of the customers both here in Australia and internationally. And we go into industries such as manufacturing, data centers, energy, and industrial properties. This diversity enables us to develop tailored solutions that address the unique energy management for each of our customers. Our client sites, we deploy smart energy solutions, including demand response, energy optimization, and storage management. These solutions integrate seamlessly to existing systems, and we leverage our AI and machine learning to enhance operational efficiency, reduce energy costs, and support sustainability goals, usually with a zero CapEx, zero OpEx model for our customers. By providing real-time insights and control, Grid Beyond helps customers maximize the value of existing energy assets, whether they be on-site generation, storage, or flex load. In terms of our software solutions, Grid Beyond software solutions help our clients to design, optimize their projects, to mitigate risk, help build a business case, and ensure operational excellence. And we have 4 variants across the software solutions. Our designer platform allows customers and clients to optimize their energy systems, which include battery storage for performance, capacity, and financial returns, and allows users to run scenarios for different system configurations to help make the business case. Our forecaster is an application which integrates into third-party trading desks, and it provides real-time forecast data which negates the need for our customers to maintain their own data scientists. So they have the trading desk, the forecaster provides the information to allow them to trade. One level up from that is our optimizer, which takes the forecast data and presents recommended trades to the third-party trading desk. So we optimize which trades need to be made. And our final solution is what we call MBAS, or Managed Battery as a Service, which is a turnkey solution from design to forecasting to optimizing to trading and then settlement with AEMO. So it's a total solution where we manage the asset. Next slide, thank you. The 2 software applications I want to discuss in some detail is our forecaster and our optimizer, and that's what helps differentiate Grid Beyond from its competitors. The forecast application integrates historical and future energy market data, weather data, network data, and other sources like demand response signals, grid conditions, asset perform data such as your battery condition. In fact, over 70 data points go into this application. We apply machine learning algorithms, it processes information, and it generates a heat map illustrated. This represents the probabilistic forecast of energy demand, generation, and pricing across various times and locations. So the trader is faced with multiple opportunities to trade that energy into different markets, be it arbitrage, be it ROI, be it IR, or FCAS. So the heat map visually conveys the likelihood of different energy outcomes, with the red representing high probability with low trade number of trades, and the blue representing smaller probability or lesser probability, but more frequent trades. While the forecaster uses AI to deliver this raw data, the trader still needs to make a decision on which markets to participate in and which will generate the greatest revenue. At the same time, taking the assets under management into consideration, such as battery cycle, battery temperature, etc., warranties. For this, we have Optimizer, which provides an asset-based trading recommendation, and we recommend which trades to make. A question I'm often asked is, you can forecast something and you can get different forecasts from different companies, but how well does that actually correlate in the real world? What really matters after you've built your battery asset is how well the actual performance tracks against perfect hindsight. So that's what really matters. Once you've built your battery, is how well does it track? The actual versus forecast performance graphs illustrated compares the predicted metrics to real outcomes. And if you look closely at the graph, you can see 2 graphs or 2 instances superimposed, the actual against perfect hindsight. This helps us track the model's reliability over time and we make further refinements in real time for future energy trades. At Grid Beyond, we have achieved perfect hindsight accuracy of 90% or more on our projects, and this compares with others that are achieving 60%. So this is our point of differentiation. Next slide, thanks. Finally, I just want to introduce the concept of front of meter and behind the meter, and these can have various configurations, and a lot of this information is available from my email. But essentially, a front of meter battery is an energy storage system directly connected to the electricity grid and subject to spot market pricing. It is designed to manage and balance energy grid services and demand. So the big batteries that the developers, the utilities are building are for grid services. The front of meter batteries can deliver various services, including frequency regulations, which helps maintain grid stability, contingency service to address unexpected power disruptions, IRR, PDRM, WDRM, and energy arbitrage, which involves buying electricity when prices are low and selling it when prices are high. Our software addresses all of those to maximize the revenue for the customer. And finally, one more slide. Front of meter and behind the meter, and again, there's various configurations. This is just the simplest to illustrate the point. Behind the meter batteries and energy storage systems installed on the customer side of the electrical meter, either through a single connection or it could be through a parent-child arrangement subject to the network operator approval. And it's typical for commercial and industrial properties. In fact, typical for a residential property as well. It helps manage energy usage by storing that energy during off-peak and when prices are low, and discharging the energy when prices are high. The battery can be charged from the grid or through solar, and the battery can also participate in various markets like arbitrage and FCAS, but also can be involved in things like self-consumption, demand management, peak demand management of the load shifting, backup power. So that gives you a quick introduction to the company. It gives you a quick introduction to our software. It helps define front of meter and behind the meter batteries. And at this stage, I'm going to hand it over to Lisa, who's going to talk about a real world case. Thank you.
Thanks, Stace. So I won't labour on too much about these first slides. Essentially, Stace has covered off a fair bit of what we do. And, you know, the journey we like to go on with our customers in terms of optimisation and the path to net zero for the whole site and the whole cycle of their business. So obviously things we look at are, you know, costs, enhancing sustainability, enabling resistance, and what are the grid constraints. By way of background, I'm going to talk you through a little bit of a case study on a live customer that we have just contracted. So essentially, they were already participating in multiple services within DSR currently. So they have, and one of their issues is they have different suppliers for different services. So they're currently participating in FCAS, WDRM, but it's across, as I said, multiple suppliers. So the first the discussions were centered around, well, how can we look at using one supplier for everything? So that started the conversation, and then taking them on the journey of that whole life cycle of where they're at and where they want to get to, we unlocked an opportunity potentially to have batteries on site. Now, this particular customer didn't want to outlay any sort of money in terms of batteries, so a funded battery proposition became quite became quite a good thing for them, particularly because it's an opportunity to unlock revenue without any OPEX or CAPEX outlay. And it's essentially a new revenue stream for them that they wouldn't have had otherwise. This here is just for anyone who's not in the cement industry, just to give you an understanding, I guess, of the process we go through and how we identify different parts of different processes. As I said, for this particular process, it's a cement manufacturing process, and this is a typical production cycle for what it would look like on a cement site globally. Essentially, what we're doing in this is we go to site, we conduct a site audit. Obviously, we deal with many cement mills around the world, so they're all very typical in the way that they in their production cycle, so we already have a great understanding. But for you guys here who don't have an understanding, typically what we would look at from an automation side is the crushers, the grinders, the pumps, the motors, and the generators. And what we're trying to do here is to find opportunities to unlock flexibility within the process, whilst not having any impact on the final product or overall productivity for the customer. Stacey's already gone through a fair bit of this, but we do actually do plant optimization models specifically for different industries as well. So laying out a cement mill industry with the types of parameters we look at are the fixed parameters, so the capacity, the conveyor rates, there's storage capacities, what the various variable asset parameters are going to be, so the different levels and the consumptions on site, the different products, the product scheduling that goes into it, and then bringing in that AI technology that Stace spoke about earlier in terms of forecasting and the predictive market analytics. We then move it over into our optimization model, which helps us create smarter decision making. So essentially the model's doing it itself. This helps to minimize production during high prices to reduce energy cost, but it also increases production volumes during low prices to reduce the overall OPEX, essentially helping us to create a more enhanced bidding strategy. So overall for the customer, it will increase demand response revenues, it'll maximise savings from load shifting in day ahead and real-time energy markets, and it minimises operational downtime. The example that we use here, so cement mills can either be on retail or it could be on the spot pricing. So this particular customer is an energy retail customer. So looking at that, what we decided to do and what we're going to be doing for them is they'll have their flexibility through their ancillary services with their flexible load on site, but then there's a whole lot of unflexible load on site which is not being utilised. So what we aim to do is to put, they've got 2 sites that we'll be putting batteries on. So there'll be a 5 megawatt battery on one of those sites and a 3 megawatt battery on the other site. And essentially, we'll be using the arbitrage model in the wholesale market to create a new revenue stream for them through this. So again, there's no outlay. It's a completely funded battery. We look after all of the maintenance, ongoing maintenance and everything for them as well. No cost to the customer. And essentially, because obviously we're moving to look at all of their optimization for them, these are the type of revenue streams that have now been unlocked. So for the 5 megawatt battery, in addition to ancillary services and wholesale demand response services annually, they'll now have a revenue stream of approximately $200,000. And that scales over the life, it scales down slightly over the life of the battery. And then for the second site, which is the 3 megawatt battery site, there's an additional $120,000. It's also worth mentioning too that the total overall revenue in terms of optimizing all of the sites and having one supplier do everything for them, it does increase by about between 10 and 15% in general, because we'll now be optimizing all of their services for them and they're not obviously utilizing different suppliers. And for anyone who knows cement, these are some of the aggregate businesses that we deal with globally down below. In terms of how we operate, essentially reach out to us if we haven't already reached out to you. We'll have a chat, have a discussion about your site, whether that's feasible, if we think there's an opportunity there for a funded battery for you. It's a great way to unlock revenue, obviously, but there might be some other things happening on site which we can assist you with as well. Get in contact. We can put together a non-binding indicative offer, which is pretty easy for us to do, and then the process sort of goes from there. And that's it. Thank you.
Brilliant.
Any questions?
Thank you so much, Lisa and Stace. Lots of different revenue opportunities there, obviously. What about the big part of someone's bill is that peak, the peak requirement from the network, that you could hit that for just one afternoon and one day of a month, and boom, the whole month is going to see that peak charge from your network. Are you managing and working with that to minimize that peak as well and make sure that bit of a peak shaving happens?
Stace, did you want to answer that?
Oh, well, yes. Sorry, I was just waiting. With a battery, if it's behind the meter, it's connected to the load. If it's connected to the same meter, yes, you can use the battery for peak shaving, but we can also do that with demand services by managing the energy use within the premises. So without a battery, just simply turning off a conveyor belt or a crusher, which doesn't operationally change anything in the facility or in the cold storage or refrigeration or data center, by turning down the cooling, you can avoid those peaks. and it doesn't affect the operation. And at the same time, the business earns a revenue stream. So this is what the optimizer does. It will select the best trading strategy with the assets that you've got deployed on site, and it doesn't always require a battery. A battery has some enhanced capabilities, but yeah, we'll do that through an assessment process.
You certainly see a future with battery prices coming down and more electrification and what have you. That are we talking essentially every industrial every industrial factory or site has a battery. It's just a matter of how big. Is that yes, is that where we're sort of headed?
Well, that's why you need experts like us. There's certainly an EMA at 5 megawatts. There's regulatory things that we've got to overcome at 5 megawatts. The battery connections are a little bit more difficult. But while the battery prices are coming down, it's just as important to look at the PCS or the inverter that's used in the droop curves to get maximum energy. Some of the inverters do not respond fast enough, and you may not be able to unlock the very fast FCAS, for instance. So when we design the system, we look at it holistically, and there's certainly selecting the right partners. I think you mentioned at the front is very important. The lowest cost item is not always the best alternative. You're not going to get maximum value out of the inverter, for instance.
Gotcha. Fabulous. And if you got some questions for Stacey, feel free to put them in there as we move on. Yeah, I'm sure we get some answers typed up there, and we'll try and get back to them at the end of the webinar. But Stacey and Lisa, thank you so much for that. Moving on now, if you're going to have batteries, pretty sure you're going to have solar. But I'd say nearly 25–30% of the industrials I speak to say, yeah, we can't do solar because of weight restrictions or a roof limitation. So when I caught up with Edwin Burnwood, the CEO of Energy and Carbon Solutions earlier this year, and he showed me just quickly through a product they've got that looks like it may well solve a lot of those issues, I thought, wow, we've got to tell more people about that. Edwin, welcome back. You've been on the webinars before for compressed air, heat pumps and other things, but great to have you here to talk about this new solar product. And I'll hand over to you to take us through this lightweight solar concept.
Thanks, introduction. I've been in energy for about 24 years. This company we've had for about 13 years and delivered over 700 projects. And we specialise in a solution where they have a problem or they need to get more grants to get a feasible solution up. So background of us, we've done everything from, as Jared said, we've done everything from specialised compressed air systems all the way through, and we're on the delivery side of projects. So we've done a lot of solar work, and occasionally we come across this problem where there's not enough structural rigidity in a building to actually get a solution on the roof. So that's what I've been asked to discuss today. Next one, Jared.
Let's go over this. We'll get moving.
You can skip over that one. Yep. So we work with a lot of very large clients. We sort of work with about 14 major ASXs on that sort of stuff. So this is your traditional type of solar system. This is a 500 kilowatt that we've just implemented for a global company, first major solar system for them anywhere in the world. This building could actually handle the panels, so that wasn't too much of a problem, but occasionally we do come across, or quite often we come across problems. So next slide. Yeah. When we did that project, I said, this is where we actually end up as a business. This is their other site. So when they implemented that first major system, our business is really around providing a solution. This solar system we just commissioned a couple of weeks ago, but with air compressors, heat pumps, energy monitoring, carbon monitoring on site, we're actually able to get this site down by 77.8% in terms of energy consumption, and only 25% of that came from the solar on the roof. So that's a 150 kilowatt we implemented there for them in a regional location. Next one, Jared. So sometimes we come across problems, and this is one of the projects we had recently, structural issues in solar systems. Well, your traditional solar panel weighs about 30 to 33 kilograms a panel. And the weight on a roof may be considerable. So most times when we're doing the structurals, you're sort of the 15 to 17 kilograms a square metre. Or per 1 megawatt, we're plus 70 tons on a roof. So if you have a big warehouse or something like that, quite often we actually see structurals fail. And the other problem with that is actually what we're looking for is the significant wind loadings. If you're putting that many panels on a roof, it's the uplift that's actually the problem, not normally the weight on the down. So now Australian standards have recently changed in that area for wind lift. We have to calculate more wind lift, which means even less roofs are now actually suitable, even closer to the edge. So we have that problem. So over 40% of industrial commercial buildings, now that we've had this, even old buildings or new buildings, we've had one recently, 25,000 square metre manufacturing plant in Queensland, needs 1.2 megawatts, but the building was actually designed that fine to get the price down that we can't go anywhere near the 15 kilograms a square metre. We've only got a limitation of 5 kilograms a square metre. So that's a building that's a brand new $100 million build, and we can't even put solar on the roof. That wasn't designed to do it. So how do we get around that? Next one, Jared. So we're seeing the emergence of these special products, the lightweight and the ultra lightweight panels. There's different classes, and these are two different products that are here. One is actually the Sunman flexible panel, and I'll talk about that one in a minute. The right-hand one there is the new Goodwee panel, and you can see it's got no aluminium around it, but these have actually bonded straight onto the roof to get around the weight and the wind lift problem. Next one, Jared. Site in Melbourne, they failed the structural inspections on traditional panels, so for their sustainability targets. We implemented a 477 kilowatt Sunman ultra lightweight panel solution. That got around the traditional issues, and we, instead of being around the 15 to 17 kilograms a square metre, we're actually at about 3.6 kilograms a square metre, and allowing the structurals to actually pass the exam. Being Pfizer, we have to go through all the normal global testing and performance guarantees and everything. So this system's still got the same system performance and warranty as normal panels, but we've got no wind lift uplift on this solution. So you can see that it's bound straight to the roof. People ask about how that's done. We've done with an architectural glue so that you've got a 25-year warranty on both the panel and also how it's structured to the roof. We've got no framing on there, so we don't have the weight and we don't have the cost associated with that. The Pfizer solution was capitalized, but you can do PPAs with this as well. A lot of lessons were learned from this solution. So system design implementation is more critical than a normal system if anyone's looking at doing this. Care in the installation to not crack the cells is essential. We did crack a few cells going through it. Performance is close to a traditional system. It's not quite the same. And maintenance and performance checking is highly recommended. The project costs are about 10 to 30% higher, but still highly viable. I think on this one, we've got about a 7-year payback. And for applications where structural constraints are applicable, then lightweight or ultra lightweight panels are a possible solution to give you those reportable carbon savings.
If you've got some questions for Edwin, throw that in the Q&A box and he'll probably get back to you and write to that one separately. But our final speakers for today, we've got Aaron Grant and Phil McArdle. Aaron from AZO and Phil McArdle from Patties, with some lovely foods there behind him. We're going to round this out because first of all, we talked about obviously batteries and our solar, but then let's bring these together and understand the bigger issues that they create and the power quality issues that need to be addressed with them to make sure this all works well together. So with that, we've got Aaron Grant from AZO, who's spent years working with the electrical systems and what have you, and absolutely passionate about power quality and loves getting this stuff right, hence the diagrams behind him. Joining him today, we have Phil McArdle, the engineering and projects and maintenance manager. 30 years in the industry of manufacturing, plenty of stories and war stories to tell, and have installed a system by AZO and got some first-hand experience for us. So, Aaron, I'll get you to share your screen and lead straight into Phil afterwards and take us through what's been done to improve power quality there.
Cool. Thanks, Jared. See it okay, I'm assuming? All good?
Yeah, gotcha.
Cool. Legend. So yes, thanks for everybody's time this afternoon. So Aaron Grant, I'm the General Manager of Power Quality Global for AZO, originally from Canada, and definitely have always had a passion and continue to have a passion for well, to use what Jared just said, get things right with power quality. I think it's I might coin that phrase. But yeah, power quality is really one of those probably appreciated areas for electrical. And that goes back even pre-VSD days. But as we go through the green energy transformation, we actually have that increasing in spades as we go along. So the purpose of this presentation, I'll try and keep it relatively short just because I really want Phil to be able to have his opportunity to talk about his site. But while we go through it, it's really just to try and emphasize the change of culture we need to have. We've gone through a lot of culture changes over the years, whether it's wearing a seatbelt, not talking on your phone as you drive, the list goes on. And this is one of those major culture shifts that we really want to try and be aware of. So just for those who don't know, so AZO is actually a global engineering company. We specialize in systems integration for energy management, power quality and energy management, and renewable energy transformation. And our solutions really do range from simple energy monitoring to utility scale power monitoring and control system, including energy operation. So in terms of what is power quality, I mean, this is showing what poor power quality is, and it's a little bit of a a very, very quick slide, but essentially what you see on the bottom left there, you want to see a nice smooth sine wave, which is your electrical grid. Certainly batteries that has been mentioned, they provide that very, very well overall, but the issue is a lot of times the loads end up causing the waveform to look like this on the bottom right hand side. And all of that really comes from all these events that you see around. They both cause poor power quality health, as well as it's a result of poor power quality. But when we look at poor power quality, and again, we're not going to go through this in detail. Anybody wants to reach out and discuss it, more than happy to. With all the distributed energy resources, or DERs, that are happening out there, we really need to make sure that we provide as clean a landscape as we can in terms of power quality health. It's no different than deciding you're going to go on a nice big hike and you haven't actually taken a look at whether or not you're healthy and ready for that. The hike is great, it's important, but you want to obviously get ready for that. So you'll generally hear terms that I use that really do have a strong connection between the human biology and site biology, because there's actually a lot of connections. But power quality disturbances, I'm not going to go through them all here, but you can see what they are. A lot of sites nowadays do have sags and swells, but then you also have the big underlying one, which I really focus a lot on, is harmonics. Now the question is oftentimes, what does harmonics come from? Again, just a very quick answer to it is ultimately, if you're looking at anything that is a power supply, so your phone or VSD, lighting upgrades, whatever, those are all nonlinear loads, and they actually distort the sine wave. Again, happy to discuss this with anybody offline if we want to look in a bit deeper detail. But the big question is that we always ask is, what is your power quality health? So again, no different than the human. You know, I'm over 40, so I definitely need to get those checkups. I might be feeling fine, but I want to make sure that I'm healthy. Or I'm actually very self-aware and I just feel that slight stitch on my side that I don't think should be there. So I go and get checked out. 80% of power quality issues with most sites actually occur from the site itself. So that's a very sobering number when given how many people don't believe they have any power quality issues. It's probably because they're not aware of the symptoms. So symptoms versus problems. But reality is, and Phil will talk to this a little bit, in about 50% of those incidents actually are mission critical. So they can cause devastating effects to the site. It could be interruptions to the process plant. It can be actual fires, which I have seen happen. But they can definitely cost quite a lot of money and really cause a big headache for the bottom line at customer sites. But the reality is, as we go on, it's very, very positive, and AZO is really at the leading edge of this, is looking for the green energy transformation and decarbonization. But the truth of it is that energy efficiency initiatives actually create power quality issues. It's the nature of increased efficiency. And so it's not ever saying, don't go down that path. It's just going, let's just pause and consider, think about, is my site health there? And when Phil will talk, that's exactly the journey that Patties went on. Initially, it was to decarbonize, but first we went, well, hold on, we had a look at the data. and your site actually requires a lot of power quality assistance. And now that it has occurred, it's ready for the green initiatives. But as a result of getting power quality healthy, the site has actually saved a boatload of money, and uptime has dramatically increased as well. So without going through all the details here, basically the green initiatives often do lead to, as we said, power quality issues. And with that increased occurrence, you're going to have facility production shutdown or breakdowns, definitely higher energy costs, maintenance, replacement costs, fire and property damage. The thing that I always like to point out to people is oftentimes customers will say, oh, we don't have any issues. And look, if you don't, happy days, it's fantastic. But a lot of the times it's because the symptoms aren't identified as potentially, and not all the time are they, but they're potentially connected back to power quality. And sometimes it's just a settings change in a VSD. Sometimes it's a lot more than that. It can be active harmonic mitigation. It can be dynamic voltage restoration, you name it. But with all this, what ASO really focuses on is our EnergyX platform that we've developed. And what it allows you to do is take all the edge level devices that you have and any that you don't have and upgrade them so that we can actually integrate them into an online cloud hosted platform that's ISO 27001 cyber secure, which is really quite critical in this age. And all that red center turns into the green center, where you do become more resilient, lower energy costs, lower maintenance costs, and property value increases. And again, these are all things that Phil will be able to briefly mention. Really, the thing is when you look at that third column there, what power qualities can lead to is damaging to site. It can be accelerated equipment wear. So oftentimes, you might want to look at your maintenance budget. Has it been increasing over years, or has it been staying the same? But you've never actually looked at ways of actually reducing that. Well, chances are probably if you remedied power quality, then you have a higher likelihood of actually reducing installation aging, for example, or accelerated equipment wear. But even energy bills, again, Phil will be able to comment on that briefly, that power quality, it's not, if you just look at energy, which is the fundamental in the sine wave, if you want to look at everything that's embedded in that sine wave, whereas what showed that before, that sine wave is all dirty, is that your power? Because if it is, that's wastage. There's a lot of waste that's in there. And so if you fix your power quality, you will actually reduce your energy usage overall. So what EnergyX through ASO actually provides for, we provide for power quality performance reporting. We can do post-event analysis, so we can actually do disturbance direction detection, which tells you if the event is from upstream or downstream. So obviously, if you can go to the utility or somewhere on your site, where did it come from? And certainly power quality compliance tracking as well. So 519, 61000, 3-7, and 4-30, et cetera, et cetera. Ultimately, a lot of the PQ events lead to a myriad of issues. And one of the sites I'll just show you quickly here, which was this is the load profile, or the sine wave that was captured. And ultimately, what the sine wave looked like, which I'm sure most of the people on this call would recognize, is the yellow line is actually what their RMS sine waves look like for the current. Which is the standard rabbit ears that happen with VSDs, et cetera. And so they actually couldn't run their cogens for about 3 years as a result. They had fires on site, et cetera. So we ended up doing a full power quality audit and analysis, and we're able to put in mitigation techniques as well as improving to set point changes. And as a result, the green sine wave is actually what happened from that. So it's incredibly amazing results. And what actually happened was the site was able to go back to their large cogens and had really good results from that. And when you do that, obviously this all leads to all these green words. I mean, it's just incredible when you see it. And again, Patties will speak to that, but you don't probably realize how much power quality is a concern until you look into it and then you fix it. And it's really quite exciting when we get to that level. So we're really at the forefront of this. As Jared indicated, I'm quite passionate, and we as a company are quite passionate about this. And we really do understand the landscape of how solar integrates, batteries integrate, and just how new load types integrate. And we use that experience in our projects across the suite of AZO's offerings and bring it back into the power quality aspect, where we again start with that health check. We find those issues, diagnose where they're coming from, recommend the solution, and implement that. And then we keep going down that line. Because it's all edge level, we have that direct access, which is really quite exciting. And generally, our customers really find a lot of value in that. Ultimately, the EnergyX platform allows for, as I said, proactive management and really being as in-depth as we want or don't want to be. But ultimately, our services team, once customers engage with us, we maintain a strong connection with them for years to come, and fast turnaround on recommendations and discussion points. I'll just skip through this briefly just because of time, but the big question usually comes in is I don't have meters, what do I do? Or I only have energy meters, which is the standard meters that are out there. No problem. We've actually developed our own power quality meters, and they're designed fit for purpose, 4G enabled, go into the EnergyX platform, and you get to have a look at it and try it out at the same time. So it's a little bit of try before you buy as well, but it really enables my engineering team to do a very fast turnaround in terms of data analysis and data capture, and work with your installers on site if we want to try some set point changes and see how that has an effect. But again, power quality it's here and it's here to stay as a poor power quality, but there are means of which that we can obtain to improve them. And then the future is green. If we can fix these issues, which we can, the results are absolutely incredible. So yeah, thank you. That's it for me.
Thanks very much, Aaron, and we'll make sure everyone gets these slides and has your contact details here. You said the results have been excellent, and that's exactly why we have Phil McArdle here from Patties. Aaron, I'll get you to stop sharing, and we'll get Phil to share his. We've got a few. Let's hit those results. I know Phil's very happy with AZO. Let's hear about it.
Great, thank you. Yeah, I'll just take you through a few of Patty's background and give you a bit of info of what we've been doing with AZO and a few other partners who partnered up with AZO for power quality. So this is Bairnsdale site down in Gippsland, Victoria. Site's been around, it's got 75-year brand history. Started up by a family, Dutch family, back in 1976. Currently around 400 plus employees. But the big thing is, like, basically the site's the largest pie manufacturer in the world. That's what then high speed as well. So we do about 46,000 tonne per year, which equates to around 563 million individual pies or sausage rolls. So it's a fairly big operation, running 24 hours a day, 6 days a week. So we produce around 1 million kilos a week on average. We average around the 900,000, but we can produce up to 1 million kilos across those 6 days, 3 shifts. And you can see the big brands there of Patties, Herbert Adams, 4 and 20, and Boscastle. So the site did basically an overview because we wanted to look at solar. I think this was back in 2022, but from AZO doing the audit on the site and looking at power quality, it was evident that we could not install solar in the condition the site was. The site had a lot of power issues over the years, and really didn't know what to do with it. They were just kind of, oops, sorry, jump forward there. They just basically put up with it. And so after what they saw from AZO's audit, we decided to do something about it. So the 12 months leading up to doing power quality, we had 448 hours downtime, which equates to about $770,000 in production. That's not in sales, that's just lost production. You basically scrap and lost output. So you can see the 82 failures across the 3 lines, and it was a myriad of different brownouts. So it's power quality was the thing basically to do. It was a sort of a no-brainer first to go in and look at what we could do. So we installed 10 AHFs, the active harmonic filters, and 7 VSDs in our refrigeration plant. Apologies, I've lost one. Oh, there we go. So, overview for site usage: 20,000 megawatts over the 12 months, a rough cost of $4 million, and emissions of 17,000 tonne, which equates to about 50 trees per tonne. So I have got a number. I think it's 80,000 trees. I think we've saved since we turned it on. So April 2024, we went live with the harmonic filters and the VSDs, and this has helped with energy saving on site of average around 9% saving. So it equates to $151,000 in savings. And from that point of switching the filters on and installation of the VSDs for refrigeration plant, we've had no internal power outages. We have had several external power outages, but nothing from internal. AusNet have given me some very interesting reasons why we've had external ones, which I won't go into, but it's there's some quite comical. But we've had, I think, since we started this back up externally, we had one this week with the high winds and high temperatures on Friday, and prior to that, I think there's another 3. We've had a car hit a power pole, and then a couple of ones on windy days through that windy period, but nothing major. So, in saying that, we've saved roughly since April around $320,000 in downtime and energy savings as well. So total savings over the 5 months, 471 as a rough number, so approximately 100,000 a month, which really the business didn't think that was going to happen. I think the whole project, it's a fairly large investment for the project, but the project really wasn't about return. It was all about power quality and really getting ready so we could install solar. But I think at the beginning, the project was only going to return something like $200,000 a year, which it's set probably it can return, if you looked at lost production, over $1 million in the 12 months. So total emissions reduction, 1,600 tons of CO2, resulting in 80,000 less trees for CO2 offset. And there's the project architecture, which is put together by AZO. As you can see along the bottom, you'll see there's the 10 harmonic filters with UPS capability yet to be installed, and the VSDs on your right vertically, and all the metering around the site. So we've got the ION 9000s and the 8000 metering, several different areas. So we have up-to-the-date energy usage, and any faults we can look at immediately. And I think we're capturing about every 5 seconds or 10 seconds data, but we can drill down into that when there's a power failure and get really right into the flickers or the sags or losses within milliseconds. So we've got full visibility of the data, and we've got data usage or energy usage, should I say, sorry, and the other ones we can see costs. So we have up to the minute of what we're using, so we can actually start then allocating costs around the plant, and really see where we're actually spending money and what the actual products are costing, so we can do a real product analysis from a cost perspective and allocate energy usage to that area. So yeah, that's basically in a nutshell, really. If you got any questions, send them through or contact me directly, and I can respond. Thank you.
Fantastic, Phil and Aaron. Congratulations on a marvelous project. $100,000 per month of hard money savings, Phil. But did you put a price tag on the headaches and the reduced headaches?
Was that working with AZO or?
Yeah.
Just working with me, mate.
I imagine with that production, you've got some happier workers around there and less panics and less late nights and things.
Well, it's just in the food waste itself, because once the lines go down, and even if it's only for 5 seconds, 10 seconds, it's the recovery of starting everything back up again. I mean, all these services, the whole plant, it's so big and vast. It just takes a lot of time to start it back up. And after 1 hour on the line, your dough quality, you've lost it, so you have to throw dough away. And we've got a live product, so from the minute you start making dough until the product's put into a box, it's nearly 3 hours by the time it goes through the process.
Yeah.
So you've got 3 hours of product. So if you're making, if we look at our fastest line, which makes party pies, it's 60,000 pies an hour. So if you equate that into weight and everything, say a party pie is 50 grams and you've got 60,000 of them every hour, that's what you're wasting.
Oh, brilliant. So such a great project. And Aaron was speaking to you a few months back, and that aha moment of as you do more energy efficiency, adding on VSDs and more electrical items and LEDs and what have you,
Yeah.
increase your issues with power factors. That to me, talking to you recently, is like, oh my goodness, there's an aha moment. You know, most of us got our heads down trying to get this stuff implemented, not realizing this is the implications and the power factor implications from that. So thanks for sharing.
And said on the back of that is that we're currently an LV customer, and with all this work that ASO have done, and it's puts in a place now that we become a HV, so we become a lot better, and then we get solar.
Yeah,
and batteries, hopefully.
It's all coming together. I hope now we see why these presentations were paired together today. First, we've got a question here from Nicholas, one for the panel. I think might be best for Stace or Lisa to answer. Along the lines of, we keep hearing battery prices are coming down, and I've seen a few wholesale residential battery prices, like they are coming down. And I'm actually starting to hear a little bit on residential, but not like the 30 or 40% that CATL or CATL seems to be talking about. Is that something for you, Lisa or Stace, to comment on? You know, where are we at with Stace with these battery prices, and when are we going to? Any thoughts on when we're going to start seeing some real decreases there?
Well, I used to deal with residential, and I know Lisa probably did as well. Residential batteries are built for the residential market. So the prices aren't coming down as fast as, say, what we can buy for a large BESS, where we're down to $200 a kilowatt hour. If you have volume buying, if you're a really big player and buy direct out of China, you're getting even better volume. But I think the residential market is built to a price and built to a market. There's also a lot of labour costs that's going into residential that you don't see on big projects. So it's all a scale issue, really. Lisa, do you want to comment on that?
Yeah, no, exactly. Similar. I would have said very similar. So yeah.
Yeah. But this that sort of trajectory, I mean, this is, yeah, I think it's what you got to make sure, if you haven't had a look at batteries in the last or consider them in the last 12 months, it's time to have another look at them. Yeah.
What I will say though is Tesla just released a new Powerwall 3, which has got MPPTs on it, which means you don't need to buy an external inverter. So you do save on the system cost is getting lower, maybe not the battery, but the system cost is getting lower. So the products are getting smarter rather than cheaper.
Yeah. Yeah. Oh, this is good. We've got another question. Looks like someone's typed in an answer there. I'm just going to dive down to that one. We had one from David Coleman here, so asking about how sites can best handle the large energy requirements of charging for electric car, etc., and 450 kilowatts requiring overnight charging. And Aaron, maybe just like to answer that one live, or we'll squeeze this in as our last answer there for you. What was your answer on that one?
Yeah, no, I was just saying that we've actually dealt with that on a large site in the USA. We're obviously using proper metering techniques and using edge level EV charging stations. You can merge those two worlds very nicely. And obviously, again, we need to understand how is everything interacting with each other. We always refer to energy orchestration. The way I like to think of it is you walk into a room, you see you hear the orchestra playing, and it's horrible, and that's because everybody has their earmuffs on, they can't hear each other. So it's all about trying to make sure that the whole system can talk to each other properly, and that's what we're able to do through an EnergyX platform. So definitely load curtailment, energy monitoring is a big part of that.
Excellent.
Maybe Jared, I'd like to add to that as well. You can actually enroll the EV charger to participate in the FCAS markets as well, because there's a flex load there. So you treat the EV load similar to what you do with refrigeration or a steel mill where your furnaces, etc. So that's something that we do in Australia. We've done it with people like Stagecoach in the United Kingdom. Secondly, besides the EnergyX platform, you can add a battery to that, which will help minimize the cost of EV charging, and you can orchestrate EV arbitrage as well. So again, that is something that we offer to our customers, and we also integrate to the EnergyX platform, because we've had a lot of discussions with James, Aaron, about integrating to the platform. We can pull data from the EnergyX into our platform and use their metering data, so we don't double up on edge controllers.
Yep.
Yeah, I'll be at the Bus and Coach show next week in Brisbane if that person is there as well.
Brilliant. One question here for Grid Beyond, and now we're talking about some big loads now from the steel industry with their electric arc furnaces, and they said that the demand is quite peaky on that one. You know, let's say moving from between 20 megawatts and 80 megawatts over very short intervals. How does that one sit with you with batteries working with that one?
Yeah, so we, and this could very well be the same company, because there's not many electric arc furnaces in Australia. So I'm guessing you're at the one of our customers at present. So we're currently working with a company who has 2 very large electric arc furnaces in Australia for their demand response applications, particularly in FCAS. And we've actually designed a whole new tool for them for an auto bidding process, which is now a tool that we're rolling out globally, because the loads are peaky, obviously, and very hard to traditionally get into the FCAS market. So to answer the question, that's the next stage of the conversation we're going to be having with that team over there is batteries and funded batteries for them. So I could be chatting to you very soon by the sounds of it. Yeah.
Fantastic. These batteries are turning into Swiss Army knives. I just try to solve this and solve this. This is great.
Yeah.
Hey, we're getting towards the end of our time, a little bit over, but there's too many good questions there to stop this. But to our panel here today, thank you so much for these presentations, and that really came together nicely, and that makes for really good messaging, and people understand the whole concept of solar options, battery, and how and power quality. So to Aaron, Stace, Lisa, Phil, and Edward, thank you so much for your presentations today.
Thank you.
Thank you, everybody.
Thanks,
And
everyone.
just to close off now, just a few little announcements to let you all know. We do have our Renewable Heat Conference coming up in just 2 weeks' time. The lineup is looking fabulous. There's going to be so many case studies from manufacturers and so many insights coming at you. Lots of networking events, and hope you can all join me for a Negroni at the rooftop bar there at the State Library of New South Wales on the Wednesday evening. That will be. Also coming up, we've got a heat pumps in the spotlight. That's next Thursday. A little heat pump tour through Melbourne CBD, reviewing a couple of new installations down there, and having a review of the one of the first major office towers to get off gas using heat pumps in Melbourne CBD. And Aaron, I'll be sure to be asking them about their power quality now that they've degasified and using electrification. So I'll throw that in the mix there. Other event we've got coming up is on the Tuesday, the 15th of October. One of our member mixers in Sydney. It's almost fully booked. I think we've already got over 40 people there for a 50 people maximum. So if you did want to jump on that one on the 15th of October, you'll have to get in really quickly. They're so popular. You'll be surrounded by other energy enthusiasts and have a fantastic evening there. So please do join us and register online from our events page there. Otherwise, if you want more A2EP, always get us on LinkedIn. I hope you're following us. We put lots of news and grant alerts and things up there. So please join us and follow us on that. Otherwise, another final thank you to our panelists, and thank you for joining us on this webinar this afternoon. You'll have those recordings and slides sent out to you early next week. If you've got any questions, let us know, and you'll have the contact details of all our presenters out with that next week as well. So hope you have a very nice, safe afternoon, and look forward to seeing you at our next webinar. Thank you.